You've probably seen or used a resistor before, whether in a classroom, a gadget, or even without realizing it in nearly every electronic device you own. But have you ever stopped to think about what it does and why? It's an essential part of electrical circuits. Let's start with a bit of context. The resistor, as we know it, has been around for over a century. Its invention was driven by the need to control electrical current as our reliance on electricity grew. While resistors come in all shapes and sizes today, their purpose remains fundamentally unchanged: to resist the flow of electric current, and by doing so manage the voltage and current in a circuit. But how does it do that? To answer that, we need to understand the scientific principle behind the resistor, Ohm's law. Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across those points and inversely proportional to the resistance. Mathematically, it's expressed as, here's what this means in simpler terms. Voltage is the push that drives electrons through a circuit. Current is the flow of those electrons. Resistance is what opposes that flow, much like friction in a mechanical system. A resistor is a device specifically designed to provide resistance, controlling how much current flows through a circuit for a given voltage. Let's look at the parts of a resistor. Most common resistors you encounter are fixed resistors, which have three main components. Resistive material. This is the core of the resistor and determines how much resistance it provides. It's made from materials like carbon, metal film, or wire-wound elements, each chosen for its ability to restrict electron flow. Leads or terminals. These are the metal wires or connectors that allow the resistor to be placed into a circuit. They act as pathways for current to enter and leave. Encapsulation. The outer coating, often ceramic or plastic, protects the resistive material from environmental damage like moisture and heat. Well, how exactly do resistors work in a circuit? When electricity flows through a resistor, it faces opposition, and this opposition has a couple of interesting effects. Heat dissipation. Some of the electrical energy is converted into heat. This is why resistors in high-power circuits can get warm or even require heat sinks to prevent overheating. Voltage drop. As the resistor impedes the current, it causes a reduction in voltage across its terminals. This is key for controlling voltages in sensitive components like microchips. There's a resistor for every application. Fixed resistors provide a constant resistance. Variable resistors, like potentiometers, allow you to adjust the resistance manually. Specialized resistors, such as thermistors, change resistance with temperature, making them useful in sensing applications. What makes the resistor so remarkable is its simplicity and universality. Despite its straightforward function, it's an indispensable tool in engineering and electronics, keeping circuits stable, efficient, and safe. It's a textbook example of how understanding and manipulating the basic principles of physics, like Ohm's law, can lead to devices that power modern life. So there you have it, a small yet vital piece of engineering that controls the flow of electrons and makes modern electronics possible.